My name is Mr. Victor Wanchuku. I was with you in the last class on business statistics and further mathematics. Last class we discussed on
Please share your material on your screen. Please share your material on your screen.
I will do that. I will do that. We proceed. Okay, last class we discussed on combination and permutation, and we did some examples and an assignment. So today we are going to continue from the course outline. So we're going to be treating probability today, probability and binomial distribution. So what we are going to be looking at today is probability and binomial distribution. So we're going to start with probability. Probability. Okay, the probability of something happening is the likelihood or chance of that thing happening. The probability of something happening is the chance or likelihood of that particular thing happening. So that's the simple definition of probability. The probability of something happening is the chance or likelihood of that particular thing happening. So you can just write it down as I take the definition for the last time. The probability of something happening is the chance or likelihood, is the chance or likelihood of that thing happening, is the chance or likelihood of that thing happening. Values of probability. Values of probability are between 1 and 0, or I can say 0 and 1. Values of probability are between 0 and 1. Values of probability are between 0 and 1. Values of probability, that's when calculating the probability, its values are between 0 and 1. It must be not, it shouldn't be more than 1. So that is the values of probability, is between 0 and 1. 0 simply means absolute uncertainty or impossibility. 0 simply means absolute uncertainty, that is uncertain or impossibility. That's what 0 stands for. That is to say that when you are saying the probability of it raining today is 0, you are actually saying that it is 100% impossible, or that is uncertain that it's going to rain today. If you are saying that the probability of you getting COVID-19 is 0, you are saying that it is 100% impossible for you to get COVID-19. While 1 stands for absolute certainty or possibility. 1 stands for absolute certainty or possibility. 1 stands for absolute certainty or possibility. That is the value of 1. So I said again that values of probability lies between 0 and 1. Values of probability lies between 0 and 1. And I said 0 simply means absolute uncertainty or impossibility. Then 1 is absolute certainty or possibility. So when you say that the probability of it raining today is 1, you are actually saying that it is definitely going to rain today. You are 100% sure that it's going to rain today. So that is the meaning of these two figures with respect to probability. So we're going to be looking at a subtopic under probability, which is expectation. 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 Like you are expecting something to happen. Expectation is the subtopic under the probability. Expectation of an event happening can be expressed mathematically. The expectation of an event happening, can write it down. The expectation of an event happening. The expectation of an event happening can be expressed mathematically as lambda is equal to P multiply N. I'm going to write it out for you to see. Lambda is equal to P multiplying N. That is P times N. Where lambda stands for the expectation of an event happening, and P is the probability of that event happening, while N is the number of in a given probability, while P is the number of attempts in a given probability. So lambda is equal to P multiplying N. You should know this down because it may be useful as you proceed further in this class. Some textbooks may not use this symbol. They might decide to use the capital letter E to signify expect. But using this symbol because most textbook uses this symbol, that's lambda. Some things call it Y upside down. That is, it's like you're writing Y upside down. That's the symbol. Lambda is equal to P times N, where P is the probability of an event happening, while the N is the number of attempts in that particular probability. So we'll go further to the next subtopic under probability. So the next subtopic under the probability is dependent events. Dependent events. Dependent events. Like you are depending on something so that you can write it down, because sometimes to write it on the board might be difficult. Dependent events. A dependent event is one in which the probability of an event happening, you can write it down. A dependent event is one in which the probability of an event happening, a dependent event is one in which the probability of an event happening, in which the probability of an event happening affects the probability of another event happening. Affect the probability of another event happening. I'll take it again. A dependent event is one in which the probability of events happening affects the probability of another event happening. Then you write in brackets without replacement. You write that in brackets. Without replacement. Without replacement. I'll take it for the last time. A dependent event is one in which the probability of an event happening affects the probability of another event happening. Then you write it without replacement. Without replacement. I'll give you an example of such events. You have if you have like 5 pen with you, or 5 pen in the probability of having 1 pen, of taking out 1 pen out of that 5 is 1/5. So that is the first event. Let's call that event A. The probability of taking that pen out of that container is 1/5. Then if you are now going to carry out a second event, that is the other event, then you now take that pen, you take another pen from there. That is, you not put back the first pen you took, you kept it somewhere else, and you now take another pen. So the probability of you having the second pen is 1/4. The first one was 1/5. Now the second one is now 1/4. You see, there is a change in the two probabilities. So 1/5 is not the same thing as 1/4. So the first event, which is 1/5, has affected the second event, that 1/4 happening. So that is the meaning of dependent event, and it has to do with without replacement. You take the first probability and you replace it. You now carry out the second probability. Then the second one is independent event. Independent. Mind you, the first one is dependent. Now this one is independent event. Independent event. An independent event is one in which the probability of an event happening does not affect the probability of another event happening. Is same definition like the first one. The difference is that the first one is it affects it, while this one it does not affect it. So independent event is one in which the probability of an event happening does not affect the probability of another event happening. So you can write in brackets with replacement. With replacement, independent event has to do with replacement. All right, let's go back to the previous example I gave. That's if you're having 5 pen in a container. If you are going to carry out the first event, that's to say the probability of getting 1 pen out of that 5, that is 1/5. You take that pen out of the 5, that single pen out of the 5, then you now replace it back. You put it back. So the total pen that you are still having there is still 5. Then you now carry out another event. Let's say that one is PB. The first event is PA. That first event is 1/5. That's the probability. Then the second event is PB. So that second event is same thing as 1/5, because your PA is equal to 1/5. You are taking a pen out of that 5. It's same thing as you taking this pen out of the 5 because you have to replace the first one. You put it in the same container. So that's that. I hope that is clear. So independent event has to do with without replacement. All right, so that's that. All these things are some key terms that you need to note as we proceed further. So that's that. Then the other one is laws of probability. That's the next subtopic. And there are different laws of probability. We have different laws of probability, like every thing that happens on Earth has law that governs it. Anything you are doing, you are actually under the law as far as we are in this Earth. Yes, so that's that. So there are different laws of probability, but in this class, we're going to consider two particular laws of probability. So the first one is additional law. Yes, the additional law, laws of probability. Laws of probability. So the first one we'll consider is the additional law. That's A. Additional law. This is recognized by the word or. That is the additional law. It's recognized by the word or. Okay, you can write it in full. It's recognized by the word or. That is O-R, or. The additional law is actually recognized by the word or, and it can be expressed mathematically as P is equal to PA plus PB plus PC plus and so on and so forth until you get to Pn. That is P, the total probability under the first law, that is the additional law, is equal to PA, P subscript A, plus PB, that is P subscript B, plus PC, that is P subscript B, dot, until you get to Pn, that is n can be any number, P subscript n. Under the additional law, the total probability is given by PA plus PB plus PC dot, and so on and so forth until you get to Pn, that is P subscript A, P subscript B, P subscript C, and so on and so forth until you get to Pn, where n, that's P subscript n, where n can be any number or any symbol that denotes the next event happening. So that's that. So number two, that's the second law we'll consider in this class, is multiplication law. Multiplication law. Multiplication law. Okay, the multiplication law is recognized by the word and. That is and, A-N-D, and. So the first one is recognized by the word or. Now the second one is recognized by the word and. So this is how you distinguish the two probabilities. So the first one is or. That's number one, O-R. Or. So if you see or if you come across a question that you see the statement or you should know the probability to use to answer that question, the law of probability to follow to answer that question. While the second one has to do with and, the word and. So multiplication law is recognized by the word and joining the probabilities. This word and is what is used to join the probabilities. So that is that. So, and mathematically, this law can be expressed as Pn, or sorry, P is where is P is the total probability. P is equal to PA. P is equal to PA plus PB plus PC dot dot. I'm sorry, not plus, multiplied by, sorry, P is equal to PA times PB times PC times PD, and so on and so forth, until you get to Pn. So under the multiplication law, you have PA times PC and times PB times PC times dot 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 until you get to Pn. Trying to write it here so that you can see what I'm saying. Times PB, this is P. You also follow what I'm saying, not what I'm writing, only follow the two of them as I'm writing, as I'm talking. I'm only trying to make it clearer. Sometimes the application you use may not be okay. All right. So so I'll just repeat the statement again. I said the multiplication law is expressed mathematically as P, that is the total probability, is equal to PA times PB multiplied by PC dot 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 until you get to Pn, just the same way you did, or we did, for the additional law. So that's that. So this is what we need to also know as we proceed further. So that's that. So with respect to this, we're going to consider a question to proceed. You're going to a question to proceed. So the question says, let me get it open for you us to see. No, not this. So the question says, the probability of a component failing in 1 year due to excessive temperature is 1/20. Due to excessive vibration is 1/25. And due to excessive humidity is 1/50. Determine the probabilities that during a 1 year period, a component A fails due to excessive temperature. A fails due to excessive temperature and excessive vibration. B fails due to excessive vibration or excessive humidity. C will not fail because of both excessive temperature and excessive humidity. If you can screenshot the question, you can do that, or I'll just give you just a minute to write it down while I take the question again. The probability of a component failing in 1 year due to excessive temperature is 1/20. Due to excessive vibration, is 1/25, and due to excessive humidity is 1/50. Determine the probabilities that during a 1 year period, a component A fails due to excessive temperature. B, due to excessive temperature and excessive vibration. B fails due to excessive vibration or excessive humidity. Then C will not fail because of both excessive temperature and excessive humidity. So to answer this question is very simple and straightforward. We are going to apply the laws of probability as we answer the question. So if you look at this question critically, they have given us the different probabilities. That is, the probability of it failing due to excessive temperature is 1/20. So you can say P subscript T is equal to 1/20. That is the probability of it failing due to excessive temperature. P subscript T is equal to 1/20. Then it to fail due to excessive vibration is 1/25. So the probability of it failing due to excessive vibration is P subscript V. P subscript V. That is 1/25. But you don't put it in fraction. You put it in decimal place. That is 4 decimal place. You're going to write it in 4 decimal place. Your final answer. Then due to excessive humidity, P subscript H is equal to 1/50. P subscript H is equal to 1/50. So these are the probabilities. So there are about 3 events happening here. So the first one is 1/20, the second one is 1/25, the third one is 1/50. Then we are now to determine the probability that it's going to fail due to excessive temperature and excessive vibration. Mind you, it says excessive temperature and excessive vibration. So there is an and statement or word there. So for it to fail due to excessive temperature and vibration, our P, that's the total probability, is equal to 1/20. That is failing due to an excessive temperature. So our P is equal to P subscript T times, not plus, is times because of the word and. So you have to call the law of probability in there, times P subscript V. That is for excessive vibration. That is the solution to the first question. Then the B part, it fails due to excessive vibration or excessive humidity. To solve this, you're going to set the P subscript VH, that is V, H, that's the total probability. P subscript V, H is equal to P subscript V, that is it failing due to excessive vibration, plus P subscript H, that's the probability of it failing due to excessive humidity. So that is how to solve the problem. So the second problem is P subscript V, H, that is the total probability, is equal to P subscript V for excessive vibration, or that or is plus P subscript H. So that is to say that our P is equal to 1/25 plus 1/50. And that will give you your final answer in 4 decimal place. Put your answer in 4 decimal place, please. That is 1/25 plus 1/50. That gives you the second answer. Then the last answer, that's C, is gotten by calculating thus. Okay, it says will not fail because of both excessive temperature and excessive humidity. All right, in the question, we are given the probabilities that it will fail, but here now it's now stating will not. The first 2 questions are will fail. That is with respect to the probabilities given in a question. But here now it's not saying will not. So if the probability of it failing for the temperature is 1/20, and the probability of it not failing due to excessive temperature is 1/50, what? It's not 1 over anything. It's 19 over 20 because you are removing 1 out of 20. So the probability of it not failing is 19 over 20. Then for the vibration, the probability of it not failing is 24 over 25. So you're taking 1 out of 25. So that is will not fail. Then the other one for the humidity, the probability that it will not fail due to excessive humidity is 49 over 50 because the probability of it failing is 1 over 50. So the probability of it not failing is 49 over 50. So you should note this down because that's what you are going to impute here. So that is to say that so the probability of it not failing because of both excessive temperature and excessive humidity is given by P subscript T H or T comma H is equal to 19 over 20 times the N here times 49 over 50. 19 over 20 times 49 over 50. So that will give you your answer in 4 decimal place. So that's that. So it's a very simple problem that you can solve. So that's that. But as we proceed in this topic further, that the probability of other topics in this course, I want you to note some certain symbol because it's what we're going to be using as we proceed. P is, Q is not. P, Q is not. I'm going to write it. You should note that P is. Just have that at the back of your mind. That is, P is means that P is that an event will happen. Then the symbol Q is the event will not happen. So that is P is, Q is not. P is, that will happen. Then Q is not. Q is not. So just know this. So perhaps in our next class, we're going to look into that in our next class. But time goes further, I would like to give you an assignment because I don't know when the time will just elapse. So I'll give you an assignment. So the assignment to be given is this one, this particular one. Is the first one, it says, determine the probabilities of drawing a white ball from a bag containing 6 black and 14 white balls. B, it said that determine the probabilities of winning a prize in a raffle by buying 6 tickets when a total of 480 tickets are sold. So this is the first assignment. Then the second assignment is this. This second assignment. The probabilities of an engine failing are given by P1 fail due to overheating. Please, you can screenshot this, please, if you can do that. Or if you are a fast writer, can try to write it out. This is second assignment, as you can see, is A2, that assignment 2. So this is the first assignment. This particular one is the first assignment. You can screenshot that. Why this is the second assignment. So our next class will be looking at binomial distribution. That is the different types of distributions. Different types of distribution. We're going to be looking at binomial distributions, Poisson distributions, and the normal distribution as we have it in our course outline for this particular course. So this is the second assignment in this particular topic under probability. The probabilities of an engine failing are given by blah, 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 blah. Please screenshot it. And this is the first assignment, that is A1. I'm only sliding or showing it to you in form of slides so that I can be able to snap or screenshot, please. All right, you know the email address to send it to. You send it to ikmc.info@gmail.com. You solve it and solve it very well. Please define the terms very well as you are solving it. ikmc.info@gmail.com. ikmc.info@gmail.com. ikmc.info. That is ikmc.info@gmail.com. 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 Please send your assignment to this email address before the next class, if there will be any next class. Thank you very much. ikmc